Let's talk about division. Division is breaking something into equal parts, and the remainder is anything left over after you divide. So we're going to go over the steps for long division. And someone told me dad, mom, sister, brother, rover. That means that we're going to start by dividing, then we're going to multiply, then we're going to subtract, bring down, and then we repeat the process until we can't do any more dividing. So let's look at an example of doing long division with whole numbers. So when we do long division, we are looking how many times does 32 go into 35? Well, that's one time. So we're doing 35 divided by 32. That's giving us 1 with some extra. So then we're going to multiply the 1 by 32. We're going to put it underneath the 35. We then subtract. So divide, multiply, subtract. I really encourage you to put the subtraction sign in another color. 35 minus 32 is 3. Then we're going to bring down the 8. Now we're going to repeat. So now we're asking ourselves, how many times does 38 get divided by 32? So 38 divided by 32 goes in one whole time. So we put the 1 up top. Again, we're going to multiply. So divide and then multiply. Then we subtract in another color always. 38 minus 32 is 6. And then we bring down the 7. Now we repeat. How many times does 67 get divided by 32? 67 divided by 32 goes in 2 times. So we put the 2 on top. We multiply 2 times 32. We get 64. We subtract. We get 3. 32 cannot divide into 3. So that's how we know we're done. And then we have our remainder of 3. We actually can write this as 112 and 3/32 because that's what we were dividing by. You could transfer that into decimal as well. So we can do the same process with polynomials. We can follow our steps. Divide, multiply, subtract, bring down, repeat. So we always start with only the first 2 terms. So we're going to ask ourselves, how many times can 6x to the third get divided by 3x? Using our exponent rules, we know we get 2x squared. Now we're going to take our 2x squared and we're going to multiply. So divide and then multiply. We multiply by the whole entire divisor. We get 6x to the third plus 8x squared. I'm then going to subtract. I always do my subtraction in another color. 6x to the third minus 6x to the third cancels. 17x squared minus 8x squared gives us 9x squared. And then we bring down the next term. We then repeat the same process. So how many times can 9x squared get divided by 3x squared? 9x squared divided by 3x. Oh, sorry, not 3x squared, 3x. So we know that's 3x. So then we multiply. And when we multiply both terms. We get 9x squared plus 12x. We come through and we subtract, always in another color. The first 2 cancel, and 27 minus 12x is going to give us 15x. Then we'll bring down the 20. Repeat the same process. How many times can 15x get divided by 3x? 15x divided by 3. I'm going to put that number up top. When we multiply by both terms. So we get 15x plus 20. We're going to subtract. We get 0. So 3x plus 4, when it divides into that polynomial, gives us 2x squared plus 3x plus 5. That means that 3x plus 4 divided evenly since there's no remainder. Long division is something that you definitely want to practice. Now there is a shortcut to division called synthetic division. Synthetic means fake, but what that means is we can't always use it. We can only use it when we have a binomial that's doing to the divisor and the binomial has an a value of 1. When we use synthetic division, we're only going to use the numbers. We remove all variables and exponents. And make sure to have placeholders if you are missing a degree. So whatever the highest degree is, you should have a placeholder for everything below. All right, synthetic division. We're going to take what we're dividing by, x minus 2, in a backwards kind of L. We're going to put the opposite but really it's the root from that divisor. Then we are just going to take the coefficients. So 2, 1, and negative 10. We always bring down the first number. So 2. Then we're going to multiply the bottom number and the number in the backwards L. We get 4, and that goes into the next column. Then we're going to add those two numbers together. 1 plus 4 is 5. Now we're going to multiply 5 times 2 and put it in the next column of 10. We're going to add together negative 10 plus 10. We get 0. The last number is always the remainder. So here we have a remainder of 0. We're going to write our answer back as a polynomial. And when we put our variables back, we drop a degree. So this was x squared. We're dropping it down to x, and then we have 5. So our answer is 2x plus 5. Let me show you one more. So we're going to set up by putting our backwards L. I'm going to put a positive 1 in there since that's the opposite of the factor they give us. I'm going to put my polynomials not in standard form, so I'm going to switch these two. So we have 4, and then negative 3, then 3, then negative 1. I want my exponents to go from the biggest exponent down to the smallest. I'm going to drop the first number, multiply. 4 times 1, we get 4. Add those two together, we get 1. We multiply. 1 times 1, we get 1. We add together, we multiply. We get 4. We add. Synthetic division is pretty quick. This number is our remainder. Our highest degree at the beginning was x to the third. So when we put our x's back in, our highest degree will be x squared plus x plus 4. And then we can add on a remainder divided by our divisor, which was x minus 1. I'll show you one more. This one, our divisor is not in the right order, so we're going to change it to x plus 5. In our backwards L, we put negative 5. X to the fourth, x to the third. I don't have an x squared, so I put a 0. I have an x, and then I don't have a constant, so I put a 0. Anytime we're missing a placeholder, we put in 0. I'm going to bring down the first number. We're going to multiply. We're going to add. 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 This number is our remainder. So we have x to the third minus 10x squared plus 50x minus 255 plus 1,275 over x plus 5. Final answer. So synthetic division is pretty fast. The more you do it, the faster you go, but it can't always be used. It can only be used when we're dividing by a binomial, so two terms, where the leading coefficient there is a 1. If it's something else, we have to go back to long division. So make sure that you practice both. We'll do a lot of synthetic division in this unit, but you need to know the long division too.